Okay, class. Our topic for today has something to do with math of physics. From what you've learned earlier, physics without mathematics is unthinkable. In fact, throughout your journey in studying physics, find out that the basic rules governing the behavior of nature are readily expressed in mathematical form. And one of the mathematical tools that we need to look on in terms of the study of physics is your scientific notation. Remember, we're dealing with quantities in physics. These are numbers, and numbers could be very large or very small. And we know for a fact that these very huge and minute magnitudes will take up much space when written. Likewise, time consuming. And to make life easier, we have to use this one tool in the study of physics to make expanded form into a scientific notation form. So it means this is a way to handle very large or very small numbers. And in order to do so, we have to follow this format, which capital N means the digit term. And this digit term is any number greater than 1 or equal to 1, but not more than 10, or it should be lesser than 10. Here, numbers are represented by the product of a multiplying factor and a power of 10. That's the reason why you've noticed base of 10. And the superscript here, symbol for superscript here is small letter n. That means the exponent. And this exponent can be any integers, positive or negative. But we have to but you have to add here in your exponent value, we can write there 0. Later, I'll intensify that part. Now, there are rules to consider when we are going to make the expanded one into scientific notation form. So take a look with these values. And you've noticed already that there are movement done, okay, in analyzing these particular values. So here, we have very large number, and in this side we have very small number. And one way to identify if we're dealing with very small number is it is written in a decimal form, or we call it as decimal number. Now, if we're going to look here first, if we deal with very large number and we want to make it into scientific notation form, we have to move the decimal point from right going to left. How many movement? We have 9 units to the left. Now here, if we're going to make it into scientific notation form, upon moving the decimal point, we have, or I mean, after moving the decimal point, we have 7 units to the right. So what is the meaning of this movement? Okay. Now, if you move from right going to left, it gives you a positive exponent. Now, if you move from left going to right, we have a negative exponent. So that's the reason why you've noticed here that the scientific notation form of this particular number is 3.25 times 10 raised to 9. Now, for this very small number, the scientific notation format now is 4 times 10 raised to negative 7. Again, the positive integer means, okay, the manner you move the decimal point. Positive because we move the decimal point from right going to left. Negative because we move the decimal point from left going to right. Okay? Now, let's apply the rules by solving these examples. So, for this particular table, we're going to make or convert the expanded form as the given here into scientific notation form. Now, let's try to apply the rules and solve it. So let's have example number one, which is 24327. So we have to make it into scientific notation. So the decimal point in terms of its movement is from right going to left, and we have to place the decimal point between numbers 2 and 4. So the movement indicates positive integer. So we have 4 movement. So putting all together, we have 2.4327 multiply times 10 rather raised to positive 4. Now, moving on to example number 2, we have 466000000. So we have to do the same, wherein we have to make it into scientific notation. So the movement is from right going to left, and that is 7 movement, and we place the decimal point between 4 and 6, indicating a positive integer. So putting all together, we have 4.66 times 10 raised to positive 7. Now, let's have example number 3. We have 0.053. So we have to make it into scientific notation. We already know the position of the decimal point. We have to move it between 5 and 3. So that indicates two movement. The direction is going to right. So that indicates negative integer. Putting all together, we have 5.3 times 10 raised to negative 2. Now, after solving, we have answers 2.4327 times 10 raised to 4. We have 4.66 times 10 raised to 7. We have 5.3 times 10 raised to negative 2. Now, let's have another example. What we're going to do in this second table is for us to make the other way around, wherein our given is a scientific notation form. We have to make it into expanded form. Now, you do the other way around of the given rules earlier to make it into expanded form. Now, let's solve it. Now, let's have an example. Number one, we have 4.0 times 10 raised to positive 3. So the exponent is in positive value. So we have to move the decimal point, okay, having that kind of movement, which is 3, from, okay, left going to right, the other way around. So 1, 2, 3. So that's the position now of your decimal point. Let's put zeros for those spaces. So we have 4,000 as the expanded form. Now for number 2, we have this given 8.97 times 10 raised to negative 4. So we have an exponent which is in negative, so we have to move the decimal point between numbers 8 and 9. How many movement? 7. But the direction is from right going to left, the other way around. So 1, 2, 3, 4. So that's the position of the decimal point. Let's put zeros on those spaces. So we have 0.000897. Now, for last example, which is number 3, we have this value 4.215 times 10 raised to negative 6. So the exponent again is in negative value. So the direction of the movement is uh, from right going to left. That is for negative exponent. So we have to move the decimal point between 4 and 2, 6 movement. So that's the new position of the decimal point. So for those spaces, let's put zeros, making it 0.000004 point, no decimal point, 4215. After solving this given, we have answers 4,000. That is still considered to be a very large number. Now for number 2, we have 0.000894. That is a very small number because that is negative. Now, for number 3, we have also a negative given here for the scientific notation form that implies a very small number. That's the reason why we have 0.00004215. Now, we're done applying the rules in writing the expanded form into scientific notation form. Likewise, writing the scientific notation form into expanded form. Now, let's proceed to operations with scientific notation. Now, from what you've learned before, there are four basic operations in mathematics: your addition and subtraction, multiplication, and division. Now, what I have here are the rules or the techniques. For addition and subtraction, before numbers in scientific notation can be added or subtracted, the exponents must be equal. Now, for multiplication, when numbers in scientific notation are multiplied, digit term is multiplied while exponents are being added. Now, for division, when numbers in scientific notation are divided, digit term is divided while exponents are being subtracted. Now, what I want you to do is to remember these rules, governing rules, when we are dealing with operations, having given that is written in scientific notation. So we're going to go back with these rules when we are to solve problems or given for this particular operations. Okay, now let's have these examples. So for number one, we are to add this given. Likewise with number two. For number 3 and 4, we have to subtract them. For number 5 and 6, we have to multiply them. And for number 7 and 8, we have to divide them. So we're going to solve each number and we have to apply the rules for each operation. So let's have example number 1. We have 1.2 times 10 raised to positive 5, and we have to add that to 5.35 times 10 raised to positive 6. So, applying the rule, we have to properly analyze between the two kung sino yung gagalawin natin in order for them to have the same exponent. So, we've decided to work with 1.2 times 10 raised to 5. So, gagalawin natin, analyzing it, we have to move 1 from right going to left to make it positive 6 because that becomes 5 plus 1, giving us the same kind of exponent with the other given. So that's the time that we can now do the addition for the digit term. Now we have 0.12 times 10 raised to 6 added to your 5.35 times 10 raised to 6. So bring down times 10 raised to 6. So 2 plus 5, 7, 1 plus 3, 4. Bring down decimal point. So 0 plus 5 is 5. Now let's have number 2. We have this given 6.91 times 10 raised to negative 2. So same operation, plus 2.4 times 10 raised to negative 3. So we have to do the same, analyze it, which among them must be altered in terms of its exponent so that they can have same exponent. So by merely analyzing, we have to work with 2.4 times 10 raised to negative 3. So we have to do the movement to going to left. Okay, so indicating positive movement, one positive movement. So that becomes 0.4, 0.24 rather. So negative 3 plus 1, so that becomes negative 2. So they have now same exponent. So we can now proceed to adding the digit terms. So 6.91 times 10 raised to negative 2 plus 0.24 times 10 raised to negative 2. Same procedure, bring down times 10 raised to negative 2. Do the addition. 1 plus 4 is 5. 9 plus 2 is 11. So 1 plus 6 is 7. Now for number 3, so we have 3.67 times 10 raised to positive 2. We have to subtract that to 1.6 times 10 raised to positive 1. So doing the same, we have to analyze which among them must be altered in terms of its exponent so that they can have the same exponent. So we've decided to work with 1.6. So we have to move the decimal point going to the left. So one movement. So that becomes 0.16 times 10. So 1 plus 1, and that becomes 2. So they have the same exponent now. So do the subtraction. 3.67 times 10 raised to 2 minus 0.16 times 10 raised to 2. So bring down times 10 raised to 2. So 6 minus 7 is 1. 6 minus 1 is 5. Bring down decimal point. So 3 minus 0 is 3. Now for number 5, we have this given 8.41 times 10 raised to negative 5. So same operation. Subtract to 7.9 times 10 raised to negative 6. So we have to analyze which among the two must be altered in terms of its exponent so that they can have the same exponent. So merely analyzing, we've decided to work with 7.9 times 10 raised to negative 6. So we have to move the decimal point going to the left, so indicating a positive movement. So we have to add positive 1 to negative 6 in order for us to get the right exponent. Same exponent, negative 6 plus 1 is negative 5. So we have 0.79 times 10 raised to negative 5. They have the same exponent now. 8.41 times 10 raised to negative 5 minus 0.79 times 10 raised to negative 5. So doing the operation, bring down times 10 raised to negative 5. So 1 minus 9 cannot be, so we have to borrow 1 from the near number. So do all the procedures necessary for it. So our final answer for this particular number is 7.62 times 10 raised to negative 5. Now, for number 5, example, we have this 4.3 times 10 raised to 8. So we have to multiply that to 2.0 times 10 raised to negative 6. So we have to multiply the digit term and add the exponent. So 4.3 times 2.0. So doing the math operation, we have this answer, 8 160. So we have to count the decimal places, having that answer 8.6. So 8 plus 6 for the exponent, that gives us 14. So writing it into scientific notation form, we have 8.6 times 10 raised to positive 14. Now for number 6, same operation, same procedure, multiply the digit term, then add the exponent. So we have 6.0 times 10 raised to positive 3 rather, multiply to 1.5 times 10 raised to negative 2. So 6.0 multiply to 1.5, doing the math thing. Okay, so we have 0, we have 30, we have 0, we have 6. Adding them, counting the decimal places, we have 2, so we have 900. So 1, 2, so 9.0. Add 3 to negative 2, we have negative 1. I mean, positive rather, positive 1. So we have 9.0 times 10 raised to positive 1. For number 7, so we have 7.8 times 10 raised to positive 3 divided by 1.2 times 10 raised to positive 4. So we have to do the operation for the digit term. So I know you know how to work with this values in terms of division. So we have 6, multiply that, we have 72, subtract that, we have 6 as the answer. So we cannot do dividing it to that particular number. So bring down 0. So we can now proceed. We have 6.5. So our answer for that particular number is 6.5 times 10 raised to, we have to subtract 3 and 4. We have negative 1. So that's the answer. 6.5 times negative 1. Now for last example, same operation. We have 1.8 times 10 raised to negative 2. Divide to 9.0 times 10 raised to positive 2. Work with the digit term, do the division thing. So we have 9.0, move the decimal point, 1.8, move the decimal point. So think of a number that can be multiplied, rather can be divided. So that can give us an answer that can work with this particular operation. So we have zero point 0.9, work with the integers, negative 2 minus 2 is negative 4. So we have 0.9 times 10 raised to negative 4. But upon checking, 0.9 is not the right digit term for scientific notation. So we have to move the decimal point on the right side. That is the right thing to do. So that becomes 9, okay? Zero point 0 times 10 raised to, we do one movement going to right, okay? No, going to right means minus. So that means negative 4 minus 1 is negative 5. So 9.0 times 10 raised to negative 5.